How's everyone doing? What a conference. What a conference. Okay, I think now you can hear me. How's everyone doing? I want to hear you. Charge me up. Come on. Someone told me I'm giving a second to last keynote, which I'm not in the same category as Aaron, sorry. But I'm looking forward to that. Anyway, empowering the individual, Rails on AI. One of the things that is really amazing over the years, over the decades, I can say now, about Rails is the way that it has allowed me to indulge my desire to experiment and make cool stuff by myself, because often that's the only way you can do it, right? You have ideas and you can't afford to hire a team or raise funding for certain things. And I find that one of the most beautiful, amazing, exciting things about the way that AI is developing is that it amplifies that kind of potential. And it 10 times amplifies it when it comes to Rails in ways that are amazing. So first of all, as more people are coming in, let me just go to the next slide. And for those of you that are not familiar with me, the Rails way is probably what I'm most famous for in this community. But I do have almost 30 years. Next year will be 30 years as a professional software developer. And I did full stack Java from 1995 to 2004. 2004 was when I fell in love with Ruby. And I was probably one of the first people in the world to be doing, to consult with Ruby and Rails at ThoughtWorks. And that was a significant experience that led me to write the Rails way and found HashRocket. And some of my old friends at HashRocket are still here in the audience, so hi to them. I did a brief AI-related project in 2019, and that's what piqued my interest. And I wanted to make sure to mention that a lot of things I'm going to talk to you about are directly extracted from my personal experience. I'm not a fan of vaporware or hand-wavy stuff that doesn't really make sense in a practical context. I want to make sure that I give you today ideas and practical inspiration and tips and tricks that you can take home to actually use on your current projects that will empower you as an individual. So everything I'm going to show you started out actually right before last year's RailsConf. I was really excited about access to the OpenAI API, and I wanted to make a contribution using that API, and I created this open source library called MagmaChat. I announced it at RailsConf and gave a lightning talk on it. And as a result of creating MagmaChat, I was able to create a bot for my partner, Victoria, who I was dating at the time, and she was working as a media partner for a conference series, and she had a copywriter. So much better. Okay. I fancy myself a stand-up comic, and I've tried stand-up comedy, so I actually like this a lot better. I don't like this thing. It's bothersome, but all right. So yeah, as a result of creating MagmaChat, I was talking to Victoria, and I said, hey, let me create you an AI copywriter for your job. And she started using it all the time. And when I saw that she was using it all the time, I said, hey, do you want to start a company together? And we started this company called Olympia. The purpose of this talk is not to hype Olympia, but I took a lot of the code that I'm going to show you out of Olympia. So therefore, I just want to make you aware of where it's coming from. In the case of what I was doing with Olympia is to create, these humanized bots. And these humanized bots give you advice in the way that ChatGPT would give you advice, but in particular roles. So for instance, a recent conversation that I had with my pair programmer, Mike, was asking him, how can I use an RSpec stub in my Rails console? I didn't remember how to do that, and he gave me that advice. So anyway, I've been super excited about the work that I'm doing in Olympia, and I gave a talk about why I thought AI was so disruptive and exciting, and it was called The Biggest Wave of All at Sin City Ruby, which is a great conference. Shout out to Jason. You should definitely go to Sin City Ruby if you can. But anyway, I gave this talk, and it was all about AI, and my friend Tom Rossi at the end, and Tom might be here as well, he said, this seems really cool, but where do I get started? And I said, wow, I think that this is really worth investing some time into helping to educate and disseminate the information that I've been learning over the last year of doing Olympia. So anyway, how can AI empower you as a Rails developer? There's really 4 steps to the enlightenment of that. So the first one, probably all of you are doing to some extent or another, which is, and I think DHH even mentioned it, which is that ChatGPT and Claude is a better Google or Stack Overflow. It's easier to, to get answers by asking these tools, and most of the time they give you good advice. So that's step 1. I'm not going to spend time talking about this because it's kind of obvious. The second one is to use AI code completion in your editor or IDE to code faster. And I'm guessing, I could ask for a show, let's ask for a show of hands. Raise your hand if you use Copilot or some sort of code completion. And as expected, almost everyone in the audience puts their hand up, right? So that's the second step. Now the third step, I think probably less of you are using, but it's to use AI to implement features that by asking the AI to code those features for you. So this would involve more than just code completion inside of a file. This involves what could be termed agentic behavior in the sense that you're collaborating with the AI and saying, hey, give me a particular new view in my Rails app, and it goes ahead and creates it for you. The fourth one, and actually what the bulk of the talk is about that I'm most excited about, is using AI to replace entire components and subsystems so that you can write less code. And writing less code is really, really where you start to reap the kind of whirlwind benefits that AI can offer, and I think is the most revolutionary part of what's coming in this AI revolution. So let's get to it. I'm going to talk about these 2 things real briefly. Use AI to help you write code is number 1, and use AI in your code so that you can write less code. Someone actually gave away the first part of my talk, so I made it really short now as a result. Thanks, Peter Ruzicka. Use Cursor AI, problem solved. He's right. Step 1, use Cursor. Sorry, GitHub. Ooh, they're sponsors. I shouldn't do that, right? It's better than Copilot and worth $20 a month. Cursor gives you the ability to do code completion. It's very good at it. You can do chat-driven changes and refactoring, by asking it to, for instance, extract. This actually solves something that I've been wanting ever since I left the Java world and stopped using JetBrains products, is that I miss those refactorings. I miss the ability to say extract a variable or pull this up a level or things like that. I have that again. And I know that RubyMine does some of those things, but this works better. When you're giving those instructions, you can give follow-up instructions. You can chat about your code base. Some of this is just, I'm going to breeze through it so I can get to the good stuff. I only found out about this a few days ago, actually. I was talking to a friend of mine about my talk, and he told me, oh, have you seen that Cursor can create files for you? I didn't realize Cursor had agentic behavior. If you hit Command-I, I'm figuring some of you may not have figured this out already as well. You can ask it to implement features on your behalf. So I don't know if it's very visible right here, but I tried this a few days ago. I asked it to add an action, and it did. So step 1, use Cursor, okay? Now, I really want to get to the meat of this talk, which is learning AI patterns, learning how to use AI components in your code so that you can reduce the amount of code that you have to write, and you can actually offload a lot of business logic and workflow and process automation and orchestration to AI. So I'm going to plug my book here. If you don't have my book already, I know a lot of you do, but this is my new book. It's a 500-page book full of patterns for how to do what I'm describing in this talk. It goes into explicit detail, not only about the big picture items around architecture, but also about concrete patterns and actual code samples. And like I said before, that code, these ideas have been extracted from working code in Olympia. Olympia is an app that has a user base that uses it all the time. We are a small, successful, cash flow positive company that is using this every day, day in, day out. What I'm about to show you. I will show you magic. This is practical magic, okay? So first of all, let me talk a little bit about the abstract patterns. Abstract patterns, as I describe them, are ways to understand how the AI fits into your code conceptually. So when you're describing to yourself in your inner voice, okay, well, what can I do with AI? Or when you're describing it to your boss, what you want to do with AI, you need to be able to describe it in terms of the architecture of the system, how they will fit in. Those abstract patterns, I know that they might be a little bit difficult to read, there's too many here, but they include things like narrowing the path, which is the way that I describe reducing the latent space, or basically focusing the AI on the task at hand. There's also retrieval augmented generation, which a lot of you are probably familiar with because it's one of the fundamental techniques for how you provide grounded information to the AI. But it also includes things that maybe you haven't heard about, like, for instance, self-healing data. It's the ability to automatically detect, diagnose, and correct anomalies in the data that flows through your system. And if you want to get even more bleeding edge with some of this stuff, there's even generative UI, which is where you're no longer explicitly designing every single screen and interaction of your user experience. You're actually setting a framework and guidelines that is then interpreted by the AI in order to create a personalized user experience on the fly. This can be affected by the profile of your user, what their previous activity has been on your system, or what they're trying to do, what their actions reveal about their intentions, and the AI adjusts the user experience on the fly. So the one I want to talk to you about today, there's two of them. The first one is called narrow the path. And the idea of narrowing the path is something that's very, very fundamental to understand as kind of one of the foundational pieces of knowledge for doing prompt engineering, okay? The reason is that the latent space, which is the high dimensional space of the knowledge that is captured in these, especially in these frontier models that have billions and now are getting into the trillions of parameters that they are trained with, is such a vastly incomprehensible large amount of data that an AI has access to on the fly, that at any given moment that you're trying to get the AI to do something with your prompt engineering, as they say, it is subject to a lot of difficulties that are not immediately apparent. So those difficulties include things like information overload. It's probably the most obvious one if you think about it. For any given thing that you ask the AI to do, it has like almost the entire history of the internet of what people have said about that thing and how to do it. So if you don't give it like temporal constraints about what time, or scope constraints, or even what domain you're operating or talking about, then it can get overloaded and get confused. There's contextual ambiguity. The way that you speak to the AI can cause it, because of that vast latent space, to not know exactly what you mean. And because AIs are trained to be helpful, that they interpret that helpful to just go ahead and give you an answer instead of saying, I don't know, or can you please clarify? There's ways around that, but that's not immediately obvious. So when I think about narrowing the path, part of narrowing the path is making sure that my context is as narrow as possible. I mentioned temporal inconsistencies and domain-specific nuances, but if you want to have a takeaway for this, narrowing the path means focusing the model's reasoning on a specific subset of possibilities. So when you're asking the AI to do something or generate a piece of content, in your prompt engineering, you want to specifically think about, okay, out of all the different ways that this could be interpreted, and then you literally maybe even list them out. And then you go, how can I narrow this path so that it doesn't go off of it? Here's an example of the abstract pattern being implemented with a concrete pattern. So the concrete pattern is called role assignment. And in the role assignment, and some of you may have done stuff like this in your own projects if you're experimenting with it, here are two different role assignments. The first one says you are a teacher giving lessons to a curious 8-year-old child. Explain how attention in LLMs works. This path has been narrowed in that a lot of terms and terminology that an 8-year-old child would not understand are eliminated from the space of possibilities, okay? That is significantly different than telling the AI that they are an NLP, or natural language processing professor, giving a lecture to comp sci postgrads, right? Okay, so narrow the path was the first abstract pattern. The second one I want to talk to you about is called multitude of workers. This one is really significant, was a breakthrough for me in terms of thinking about how to design and use AI inside of my Rails applications, okay? The idea is that you can decompose your workflows, you could substitute business logic in there, into collaborating, almost human, discrete components. It's almost like having little human-like microservices that live inside of your code, okay? They don't have to live outside, they're not hosted on some external system. These are code modules inside of your code, okay? You ask these code modules, these discrete AI components, your multitude of workers, if you will, to perform specific tasks or make complex decisions in ways that you would have otherwise had to code imperatively or using just normal programming methods. So the reason I got to this, realistically, you know, I worked at ThoughtWorks, had the honor of being mentored by people like Martin Fowler and Fred George, especially, who originated a lot of the thinking around microservices to begin with. But also, the first O programming language that I used was Smalltalk. And in Smalltalk, we think about interactions between objects as messages that are being kind of spoken between these objects. With the case of discrete AI components and a multitude of workers approach, you can actually speak, you know, between these objects in ways that are pretty much plain language English, right? So in my example here, one component might tell another one, user 7482 hasn't logged in recently. The component would reply, let me look at their activity history. It goes and looks at it. And then based on that, it says, okay, I'll send them an email about our latest new feature as a way to maybe generate some engagement, okay? That's the kind of thing I'm talking about. Seems a little loosey-goosey, maybe hand-wavy, and if you're skeptical, I understand. But there's benefits that we'll get into very soon. Another foundation for this is actually behavior-driven development, in the sense that what we were trying to do 10 and 20 years ago, when BDD was like a really, really hot thing, some of you may remember, is to describe in plain language what we wanted our system to do. And in fact, at HashRocket, one of the things that we pioneered was actually making the basis of our requirements, and even in some cases our contract negotiation, these definitions done in Cucumber using BDD techniques. So I was immersed in this and helped drive this forward. So I feel like those of us that had the the pleasure and sometimes the pain, realistically, of doing this stuff, are kind of positioned to think about it. I'm very influenced, and I owe a debt of gratitude to Aslak and Stephen Baker. This was at RubyConf 2005, so a little bit of history and trivia. This is where RSpec was started, literally the first lines of code for what became RSpec, and also some of the lines of code that later became Cucumber were written at RubyConf 2005, which is also where I took this picture that I posted on Twitter yesterday. Hi, Toby. Thanks for coming to my talk. I don't know if David is here as well, but yeah, fun times. Okay, so I don't know if magic triggers anyone in this room. It certainly triggers other people out there in the world that have not been indoctrinated properly. Thanks for saying that in your keynote today. I do think we need to indoctrinate people more, by the way. But yeah, sorry, don't get triggered. I'm going to show you some magic. Okay, I mentioned Olympia before, and I mentioned that some of these techniques are directly extracted from Olympia. In Olympia, one of the things that you can do is to add additional bots to your account if you don't already have them. In this case, what I'm showing here is that Shandell is an optional bot that has not been added to the account. And I'm going to show you the way that I implement the addition of a bot to a user's account, okay? That's done with an account manager class. The account manager class is one of these multitude of workers that I use to collaborate inside of the Olympia code base. And the prompt that drives that account manager class at Olympia reads like this. I'm not going to read the whole thing. I'll just read the first paragraph. You're an intelligent account manager for Olympia. The user will request changes to their account, and you will process those changes by invoking one or more of the functions provided. Escalate to human support rep if you encounter any problems, okay? This is almost the entire prompt. There's a few other details that I left out for clarity. Here are the functions that are available to the account manager as tools that they can use to do their job when they're processing changes to the account. Since one of the main things that I ask it to do is to handle adding bots to accounts, they have an add bot config to account. They can add a new line item to the subscription. They can notify the account owner, and they can call a method is completed. I actually left one out by mistake. They can also contact customer support. They can literally like cause a ticket to be filed, okay? There's no AI magic going on in the implementation of these functions. The implementation of these functions is just normal, in this case, sorry, shitty Rails code that does the thing that it says that it does, in this case, adding bot config to account. Interestingly enough, I rolled this out to production, and a week later, JP, one of our great customer support reps, contacted me in Slack and said, hey, we have a situation with a user who had scheduled their account for cancellation. Their account is not canceled yet, but it's not in an active state, and they added a bot to their account, and it worked. And I don't think that's correct. This was just a missing requirement. This kind of thing happens all the time, right? So I said, yeah, that doesn't seem right. I think we should probably not let people who are scheduled to be canceled add new things to their account. So he said, great, do you want me to add a Notion story for it? And I said, no, I think I already got it. And what I had done was basically go in and write this new line: do not allow the user to change their account or add a new AI assistant unless their account subscription is active. I don't have time to get into like the actual implementation of how the account manager interacts with the rest of the system, but I want to make it clear that this actually did work. So I did some ad hoc testing, admittedly, to see what would happen with this new change to the prompt. And what happened was that the account manager sent me a notification saying, hey, I'm sorry, your account is not in active state, therefore I cannot add this bot to your account. I don't know, does this seem magical to anyone? It seemed pretty magical to me. This is not for everyone. Maybe you don't want to make patients' lives or jet planes flying through the air dependent on this sort of thing. But one of the times I mentioned this before, someone said, hey, aren't you afraid this will hallucinate a bad result or send do something that's not to do? The truth is, with narrowing the path and giving explicit instructions, this works, I think, about as well as a human would work. This is pretty basic stuff that you're asking it to do, and it seems to be well within the reasoning capabilities of the state-of-the-art models. And in fact, one of the reasons that this works, and one of the reasons I think the material in this talk is important, is because of the architectural approach. If you took a naive approach to doing this sort of thing, you might lard your entire component with literally all of the business rules of your business, or so much information that it gets overwhelmed or confused and does the wrong thing. And then you might go, hey, this approach doesn't work, it sucks, Obie's lying, blah, blah, blah. No, that's not the case. The case is just that you haven't made that component small enough, right? When you do these narrowly scoped techniques, they actually work. So anyway, that's my multitude of workers pattern. There's applications, I think, in account management, which I just showed you, but also e-commerce. I know a lot of you work in e-commerce. Like half the conference is Shopify, right? Yeah, so, okay. Product recommendations, fraud detection, sentiment analysis, et cetera. There's healthcare applications as well. I wanted to mention before I end the talk some of the concrete patterns so that you see that these can actually be kind of fun. There's 28 concrete patterns in the book. I'm looking at them real quick. I mean, with a couple of exceptions, they're all extracted from working code. It's very, very crucially important to me that patterns are extracted from real working code, right? A lot of the patterns have to do with prompt engineering. For instance, structured I/O. This is a pattern that describes how you provide your input data to the LLM AI in a way that predisposes it to be able to understand as data, as opposed to just a conversation, hey Joe, like how you doing today? Okay, now this grounds, it narrows the path, okay, to use the example, for the AI that the way that you want to interact with it now is as a machine, that is, you're going to give it data. And in fact, one of my predictions that I made is that XML will make a comeback because it's actually super, super trivial to parse XML using regular expressions, and you can do things like this. So in this case, an example taken from the book, I give it a description, and I'm wanting to get name, size, price, and color from the product description. The fact that I have already put this into XML format means that it's going to very, very quickly say, oh, he wants XML back. I don't have to do a lot of extra prompting and prompt engineering to get this result. Another example, concrete pattern that's used in prompt engineering is the ventriloquist pattern, which I think is really, really fun. Okay, it almost feels like a hack. A lot of this stuff almost feels like a hack, but it actually works really, really well. The idea when using the ventriloquist pattern is that you plan the desired outcome from the AI's response, but the way that you narrow the path is by speaking on behalf of the AI. You're using it like a puppet in a way. You're providing part of the interaction that you have in that conversational cycle with the AI, and I'll show you an example of that. So this is a real class from Olympia that in the case that the search that the user did, or caused to happen more precisely, did not return any results, I want to produce some alternate keywords which I will now use to do a search again and try to bring back results. So if I call your attention, I don't think I have a laser here unfortunately, but if I call your attention to the middle method there, which is where I assembled a transcript, the system prompt, which is the directive that kind of sets the tone for what is going on here, is you are a powerful web search engine. So here I'm doing a role assignment, okay? I'm providing the input from the user, and the input from the user was their original question that they asked that they didn't get a result from. Now, I'm not going to tell in the prompt all this. I'm not going to say, hey, the user didn't get the results. I'm actually going to simulate, and that's why I call it ventriloquist. The user asked a question, the assistant said searching, no results found. This is congruent with the fact that it's a search engine. And then I'm providing the prompt, and the prompt says, matching the original language of the question, generate 3 alternate keywords that might produce better results. The reason I did it this way was not just to be clever, not just because it was a hack or an interesting example for the book. I literally did this because I was struggling with the other approach, with the more just kind of direct approach of like, hey, generate alternate keywords for this terms, right? Like I was doing that and it just wasn't performing very well, and then one day I decided, hey, I could use this ventriloquist kind of thing, and it actually worked really well. It understood much, much better what I was trying to do. Some of the other concrete patterns have to do with how you create discrete components. An example of a discrete component would be a predicate. Now, if you've done Ruby long enough, you're an expert in Ruby, you know that the question mark methods are called predicates because they are return Booleans, right? True or false result. And a predicate pattern, as far as I'm concerned with AI, is one in which you ask the AI a question that is designed to give you a yes or no answer or a true or false answer. One of the side benefits being that you can ask for it to explain its reasoning. Okay, so here's an example. I'm not going to read you this whole thing, but at the beginning of this prompt, you give a transcript of a conversation, and the idea for this particular predicate class is to analyze what the user is talking about and then answer the question, does the transcript contain enough context for the assistant to be able to answer the user question without making assumptions? If you think about the fact that Olympia is, kind of like a ChatGPT, and we do, we have long-term memory, and we search that long-term memory in order to provide proper answers to the prompts, this is a very useful thing for us to know whether there's enough context in the conversation as it's gone so far in order to do that search. So here's another concrete example. I'm just going to go through it real quickly. An API facade is something that's actually almost directly taken from Gregor Hope's classic patterns of enterprise integration. But when we do it as a discrete AI component, what that API facade pattern lets us do is to go from a generalized AI assistant that knows that it can do certain capabilities like interact with the user's email, but it doesn't lard the context of that general assistant with all the specific implementation details of how an API works. In the case of Olympia, Olympia assistants can help you with your Gmail. But if I put all of the Gmail capabilities, or even a subset of them, of the API that's available into the main conversation loop, it would get that assistant confused very quickly. So we use the API facade to basically set up that bridge to give the main assistant, the general assistant, more capabilities than it would otherwise. Anyway, a lot of the examples that I've showed here today are based on my own little library called Ray. That's Ruby AI extensions. You can find it at our Olympia GitHub. And everything that I've shown you today is described in a lot of detail in my book, Patterns of Application Development Using AI, which I'm super excited to say that Gregor Hopi, who I mentioned a minute ago, is writing the foreword for. And as soon as he sends it to me, which should be any day now, we're going to get this published in hard copy as well. So if you want it today, it is available and pretty much done on LeanPub, or you can wait for it to come out on all the platforms. But anyway, I hope you get a lot of use from this, and I hope you enjoy the rest of the conference, and I'll be available if you have any questions. Thank you very much.